That would help. Okay. Fourth day this week. Talk about some these letters and numbers. But before we do that, maybe we'll go just like we did for previous days. We'll go around the room and we'll for JavaScript specific, right? Just mention one thing. Excuse me, one thing that that's going well for you in JavaScript, even if it's just this week, and one thing that's still struggling, even if it's overall or just this week. So we want to start. Dakir, you want to start again? Okay, we'll start with Kelly.
Okay, I'll go.
Okay.
So, like I said, I was really able to understand when we did the map for each, and we incorporated it into the document that yesterday, and I saw all that. And I like that I was able to understand when we put all those options and everything in, and we saw the end result. Finding the time to do it on my own and actually get it to work. I can't ever do anything. I can't. When I go to do it on my own, I never get it. It doesn't work. I'll just stop. So I get frustrated.
So the struggle part is getting it to work after you've seen it. Okay.
That's my biggest.
Huge gulf between understanding you doing it and doing it myself.
Right, exactly. Wants to go next?
I'll go. I don't know what to say. I think the exercises yesterday were helpful again. I like doing this on IPS. That was way less excruciating than I thought it was going to be.
Hey, we're gonna create a front end framework.
Yeah. I was like way flopped up.
Oh, okay.
And so that was cool. I was excited. I'm feeling more like confident in like being able to participate. So that's I think a good sign because I feel like I'm starting to know more about what I'm talking about. And I think I'm still just trying to like hammer at home like the order to put things in and like remembering how to call certain things.
Gotcha.
Not like particularly very frustrated.
I'm partially where I can see you do it and I'm like, yep, absolutely. And then if I go to do it myself, I'm like, what am I gonna do? So
Yeah.
I think it's just because most of the time when I'm trying to figure something out, I take something that we've done and then I try and like apply it there, and sometimes that works, and sometimes it really doesn't. So it's just getting used to the differences in why you're doing, like why you're building something in one way and not in another.
Right. Okay. So the reason why you'd use that specific tool, so to speak, right? Okay. Well, maybe we can go kind of like that list thing. We'll list a bunch of different JavaScript methods and concepts and stuff, and we'll just a reason why you'd use it.
Oh, that would be really.
Would that be helpful?
That would be really helpful.
What should we start off with that?
Sure.
Yeah.
Okay. But before we do, any others that want to chime in there? So just a general, let's, yeah, okay.
I like the pace that you go at, and how you explain things. It's really helped me understand some stuff that was foggy from the beginning.
Okay, that's good. I'm trying. So this whole week, I've intentionally forced myself to slow down when I talk. Normally when I talk about this, I talk very fast. One, I get excited about talking about it, and two, it's just kind of like my normal speed when I talk about pro. See, I'm already starting to. Yeah. Anyway, but any other subjects other than like programming in general, I don't talk very fast at all. Just like, yeah. but I don't know why. I just tend to speed up. So I've been trying to keep the pace, like you said, but also trying to incorporate as much as I can in the time that we have together and have it be meaningful, right? Can't throw too many high, complex things right from the start, right? Anything else before we start making a list?
I like what you said about the baby.
Yep. Okay.
I like your energy.
Oh, thanks. A lot of coffee.
Yeah, it's just your, it's break. Maybe that's the coffee.
It's mostly coffee.
I like Adderall myself.
most days I am super exhausted and tired. I have a very, just like Caitlin over here. Actually have a very busy schedule. So I completely
I mean, I know I'm not the only one, but like,
I completely understand.
I
Yeah.
hate complaining about it. It's like, I really try not to complain.
Yep. I go from getting up in the first thing I do in the day, to the last is just like I barely have time for myself.
My kids-
And part of that's my fault too.
Well,
I put
think
too
I'm
much on myself.
workaholic, so I kind of dug myself into this hole.
All right, so let me get a new Google spreadsheet open. New.
It's on the plate. I just.
It landed the right way.
It's on the plate. Say your plate has cat superpowers.
All right, so
They really that really did me in being here today. I was
All right.
most uncomfortable day that I've had in a long
All day I'd be like,
and then
and then I like put my feet in a prepared. So do you mostly work in the console? You mostly just.
in my day to day,
Yeah.
no, I actually work mostly in Visual Studio, not Visual Studio Code. So it's like the enterprise edition. So we all have subscriptions at work, and I mostly 99% of my day is in that. But when I need to in Visual Studio,
90% of my day is.
oh, I said in that, meaning in Visual Studio.
Yeah, exactly.
But when I need to solve a quick problem and it's like something to do with the UI, I jump right in the console or Scratch or something. I do use that tool a lot, just not as much as just straight up Visual Studio. Mostly just for when I want to experiment. All right, so let's go through. Maybe we'll start with some functions that we've talked about, why you'd want to use it. So we'll say start with array functions. I didn't structure this right, so we'll just do this. Let's say for each. Can I? Oh, I can't do that. Then we had map. Filter. We didn't talk about this one yet, but I'm going to put it up there because I will mention it today. And what else is it? Then we have for loops, while loops. When I'd want to, let me just do this. An array itself, when do I want to use that? Object, and then there's object.key. Keys. What others that have come up?
Max mentioned prototype and constructors.
Prototype. Constructors. Slice. Okay. There's also array splice. That as well.
What about, one thing we talked about is switch.
Oh, switch. Yep, that's control flow. That's if then else sort of logic. What others? Has own property. Yes, that's an object, or yeah, object. Has own property. This. We talked about arguments.
Can we talk about state?
State. The concept of state, sure. Sync versus. Oh, we'll just say sync. I think. Okay. What others? Or do we want to start going through this?
Start. Others might come up.
Okay. All right, so arrays, when I'd want to use these, this is when I have a collection of data that are typically all of the same type of data. So for example, we'll just say example. Can I make just this a little smaller? Is that okay? Can you still read that? I just need, let's say an array of, I'm gonna do it this way. We're gonna call this a list. That's kind of what it is anyways. So I have a list of database records, right? I have a list of these things. I want to do something with them. I have a collection of them. I have a result. Maybe I did a query against the database and I got this as my result. I wanted to see all employees that have salaries higher than 6 figures. If I get back a list that's extremely long, I know I'm at a great company. If I get none, well, something to shoot for, right? But anyway, so there's a list of things, right? Usually all of the same type. You can arrays can have elements of any type together, but that's not typical.
Is it the reason that you select or that you choose to use an array, is the reason for that because it stays in order?
That's one reason. Yep.
Is it like a simpler object to use, or?
I wouldn't say it's a simple concept, right? So I have a list of to-do things I need to do for the day, and they're in a specific order, or a list of appointments I have for the day. They're in a very specific order. So if I had an array of things that represent those appointments, I know that the first one's always in this spot, the second one, and so on and so forth.
Okay.
Right? Keeps in order. Can iterate over, loop over. Right, so those are reasons why. Array for each is simply a way to iterate, loop over every element in the array, and then do something with it. So an example would be like what we did with TinyFEF, right? So I want to use each element and apply it elsewhere. I'll put TinyFEF as an example in there, simply because you all have done it. I wouldn't have done it in there if we only glanced over it, but hopefully that will make sense there. Okay, map. Any other questions on arrays or for each before I move on? Or are we good? All right, so map is also a way to iterate over, but then transform or manipulate each element and use here. And so an example of this would be, in fact, there is an example in TinyFEF where I have a collection. Let's say I have a collection of data that needs to be transformed into actual visual elements on a web page, right? So for each one of these things, I'm going to transform it in some way, and I'm going to apply it to the DOM. That would be a very useful thing to do. We're going to use that a lot in React when we get to that. Filter, also a way to iterate over, and then only keep the elements that pass the test you give it. So in this case, it would be, let's see, retrieving let's say a certain grade from,
Oh, so like when I filter all the grades for kids like that. And I feel like filter my whole list.
yes. So you want to see, let's say you
So
want
it'd
to,
be like all grades below 66.
right, so you want to find all grades below a certain, what do you call it, grade point or whatever, right? I have this list of grades. I want to see everyone who's not getting to 65, so I know how to help them. Yes, so returns a new array. That also returns a new array.
You want it to wrap in the confines of the column.
Do we want to do that?
Yes, please.
If you highlight D and then you go to format, and then text wrapping and then wrap.
Maybe I just don't have enough on my screen. Where's wrap in here? Oh, it's on the, is that hidden?
It might be if you click the arrow.
Oh, that's
pointing
why.
down.
There we go. So I'm just going to do this format. Text wrapping. Wrap. There we go. Awesome. And that's a wrap. All right.
Did you see as well? Please call and see.
Oh, yeah.
I didn't make you do that.
The only reason why I know that is I had to do it.
Yeah, no.
Well, if this was like actual like Excel, I'd be like, oh, click. But yeah.
I didn't make you do it.
All right. So reduce. This is also a way to iterate. We'll touch on this today. Itarge, yeah. Iterate over, and then how do I say this? Combine all the values into one. So if I have a perfect example of the usage of reduce is if I have a list of numbers that need to be summed. Right. So if I have a list of 28 numbers and I want to know what they all are added together, I could use reduce to do that. You could also use it if you have a list of objects, a list of database records, and you want to combine, you want to create one gigantic record out of those somehow, you could use it to do that too. That's a lot more complex, but the simplest way to use it is just to create one value from all of the values, right? Sum is a perfect example of its usage. For loops are just, this is a generic way to iterate over, actually just a generic way to iterate, right? It doesn't have to be over anything. It could just be from, you know, as long as I is 20 and I start at 0, just do this many times, right? An example of that, I don't really for all that often. I use for each because I'm iterating usually on purpose, not that for is on purpose. There's an intent in the iteration in the context of why it's being used. Let's see. So for is just, oh, actually, loop over an array like object. You could loop over that arguments thing, right? Because every one of those arguments has an index. It's not an actual array. It's just this array-like thing, but we can loop over that. That's one way to do it. A while loop, the generic way to iterate while a certain condition is true, right? So if I were to say something like, oh, let's see. Let's say that I want to keep checking if a connection is available. So while this connection is not available, try to connect. Let's just say there's an API that sends me back a message that says, hey, you're connected. Okay, so if I get a message back that says you're not connected, well, that condition's still true. I'm not connected. So try again, try again, try again. So if you are connected and the connection drops, a while loop would be a way in that particular code to try to reconnect. In fact, we do something similar in a product that we're creating right now at work. An object. So an object, what are we doing? So the reason we would use this is that holds, let's see. Right? So if I have an object, it represents one thing. Right? So a database record is one object. It has a name, maybe has an age, maybe it has some other things related to it. Not all the values are of the same type. It could be numbers, it could be strings, it could be arrays of other things, but that object represents a single thing. Single thing. Easiest way to say that. Where to use this? There's not a lot of places you can't use these things, so it's hard to narrow down. Actually, a database record really would be displaying data from a database record. We want to display this thing, so we get this object back, and then we can iterate over the properties or just access certain properties and grab the data that way. So this is a way to iterate, or a way to get all the property names in an object. And a perfect reason for using that, again, the tiny FEF, right? So when given an object that represents options to be applied to, let's say, DOM elements, right? And I'll just put a reference to tiny FEF. Whoa, not that. How else will we get that out? We can't iterate objects, so we have that method to be able to do that. Prototype and constructors.
Anything like that. So is there anything that's not an object?
So there are base types in JavaScript: object, string, number, Boolean, null, undefined. Everything else kind of stems from that. None? Oh, yeah, none, yeah. NaN, not a number. That's its own thing as well. I feel like that's too many, though. I feel like those are also abstractions. But yeah, so objects are like a lot of what you're using. Anything that has a method on it, like this thing dot whatever, it's probably an object. Right, so if I say array dot map, map is a method on the array.
Like,
Yes, so that array itself has methods attached to it that can be accessed, right? So if I say they are, right? But the value of that is the function.
like he's
Yeah, so the key called map is the value of that key is a function that iterates over that array. Yep. In its simplest form, that's all it is. Right? It's this object thing with these methods on it. They're just keys with values. Yep. Think of it that way. Yep. Or through dot notation too. But if you use dot notation, remember you have to be explicit about what that name is. You can't like plug a variable after the dot. Right? Whereas if you use the square brackets, you can evaluate what's the value in that variable and use that as the key. Okay, prototype and constructors. So these are related to the base functionality. So base functionality of the type. Let's see, of the native. Yeah, we'll just say of the type for now, until I can find a better way to say this. So and I'll go over constructors as well. So if I were to, so in another language, we have there's classes. And so like in C or C sharp, you have a base class, and they don't really have prototypes. They have base methods and properties. So JavaScript uses this prototype concept to mimic that same type of behavior. And so in JavaScript, if I were to write a class, now there is the class keyword. You can actually define it that way. But before that came along, and really class, I think just translates, it gets compiled down into this anyway. You would create a function, and let's just call this like the animal I gave the other day. I have this function animal, and what it returns will just be some object, and it has some properties on it. We'll say one is the, say has legs, and number of heads, right? Maybe it's a hydra, I don't know. Anyway, so we have this animal. Actually, let's do something else. Let's say number of legs, and we'll say speak. Does it speak, or what type of speak does it do? This will be a little bit easier. And so I'm going to get back this return object, and I need some values here, right? Because I have this object, so there's keys and values. What am I going to put in here? So when I create an animal based on this kind of like blueprint, what I'm going to do is I'm going to tell it how many legs it has and its method for speaking. It's the same. Naming is hard. It really is. We'll say type of speak. What I'm going to do, actually, I'm not going to return this because it will do it for me. I'm going to say, so when I get this function, I'm going to say this dot number of legs, and this dot type of speak, or this type speak. What's the type of speak? This is going to make sense in just a second. All right, so this is like a blueprint for an animal. It has base properties on these things, and let's just do let's also do a base method. We'll say this dot say something as a function. And all it's going to do is it's going to console.log whatever the this dot speak is. I'll run this. Now, if I want to create an instance of this thing, like I want to create an animal, I would say, let's say var animal equals a new animal. Now, when I create this new animal, it's expecting legs and type of speak. So we'll just say for and bark. Now, if I type animal, we see this thing. It's got these things on it. If I say animal dot say something, barks. So that say something, that is a prototype method available on this particular animal object, right? So the prototype for, it's such a hard concept to talk about. If I were to say, let's say that I wanted to also add more functionality, this will actually make more sense. If I add more functionality to this thing, maybe we'll say animal dot prototype dot blink is a function. Now down here, I'm going to create a new animal again. Right now it has, I put number of left. Okay, yeah, well, it's supposed to be number of legs. This dot speak and it has this dot say something, and those are all available. Animal dot prototype dot blink is something else that's available on it. That prototype means that every instance of this animal thing is also going to have this other method on it, no matter when I create it after the fact. So the prototype is kind of like saying, whatever this base thing is, give it this functionality so that when you create a new one, it'll have that as well. That's kind of the concept of it. You typically won't use this very often or at all.
The old one have it?
The old one didn't.
So the old one didn't, and then you said prototype, and you gave it a new.
Right. So
property,
initially, it didn't have blink.
right?
Right? But after the fact, I said, hey, any animal you create from now on, it also has a blink method on it.
Okay, so the old ones won't have it, but the new ones will.
Yes.
Okay.
So if you define this function and create a new thing, let's say right in here, I say var animal equals a new animal. Can't type today. In the console, if I say animal dot blink. Okay, so Chrome did a very nice way of doing it for me. Typically, I don't do this, probably because there's this other concept of hoisting where it pulls things up. But if this was, let's say I imported this from another module, and that module added these prototype methods, from there on out, you'd have these methods on it. It's a little bit confusing.
Okay, can we just like make this a little more real world? Like if there was a form and now there's a new form that has a new parameter on it.
A form, sure. Yeah.
Let's say it was a form, and so now you need to add that new parameter so it knows what to do with the data. Does that make sense? Like you go to
Yes.
your doctor's office and you fill out. a
Gotcha.
form, Now they have a new, like cell phones, for example, when they were relatively new. They started adding cell phone numbers, but if you looked at old records, they wouldn't have a cell phone number. Because cell phones didn't exist. So is that the kind of situation you would use this for?
That's a good example of how you'd use it.
Okay.
In real world, you wouldn't do it this way, right?
Okay.
You would update the module that has all that stuff. You wouldn't assign it after the fact.
Okay.
But that's a great example of how that would yes,
Okay.
that's exactly it. You got it. It's adding functionality to something that didn't have it before.
Okay.
Right? But the prototype also means that that's the functionality on that base type, whether it came before or didn't, right? That's how we access it or add to it or manipulate it. So when we said array.prototype.map2, every single array after that now has map 2. Let's see. Oh, adding new properties to a form type.
So like ice cream has like, you know, like let's say we got French, they got all these different flavors. But there's this base ice cream that they use to make all their other flavors.
Something with no flavor to it.
Right, so that's the prototype.
That is the base type. Each flavor would be considered the prototype properties on that base. Or no, it'll actually be more the ingredients, really. Because you can have different types of flavors of ice cream, but they're all frozen. They're all made from cream or almond milk or whatever, right? So the ingredients would be like the prototype properties, right? And then a prototype method could be brain freeze. They all have it. If you eat any one of them too fast, you're gonna get it. But that's something that every single instance of it has, right? So that's that prototype. It's a weird word. It's just something you got to use too. Yeah, and the constructor really, when you create a new one of those, that sets it up. Kind of like how I did that, like this stuff. It's kind of like that sort of thing. All right, array.slice creates a new array from the original and can optionally keep only parts of it. This would be a perfect usage for this we saw the other day, where we need to create an actual array from something that is not an actual array. That's it. Usage for slice. Another usage for slice is it gives you a new array. You could just get a copy of something. Right, so I can also put that down, or get a copy of an array. Did anyone mention like values versus references when talking about like objects or strings or arrays? Did anyone mention that at all? So if I have a variable and I set it to an object, did he explain that that's what's in that variable is not the object itself, but a reference to it? Did they mention that at all? I want to touch on that because that's a very important. It's one thing that bites everyone at some point. It just does. So it's a great way to do this would be, I'm going to create this better. I don't want to be too small on this one. This is an important point. Let's say my object equals this object has a name, Joey. And we'll say name equals, just so that same word, different casing. So now if I were to say name, I see Joey. If I say my object, I also see this thing. But what's really happening is that inside this my object variable is a reference to this object in memory, not the actual object. Because it's more of a complex type, it can store more things, right? Whereas this is just a base string value. What it is what it is. You can't really change it. You can reassign name to something else, but you can't really change this. But the object can change. I could change the property name to something else. Right? I can add new properties. I can add methods to it. I can do all those things. I can remove properties. So what's inside my object is a reference to where that thing is, right? And the important thing to know about that is that, let's say you have, what would be a good example? Arrays are the same thing. Maybe we'll do it with an array as well. So my array equals this array of numbers. The variable of my array is just a reference to that array somewhere in memory. So let's say you have, actually a perfect example. Let's say you have an array of objects. You say, okay, I want to make a copy of these things. So let's do that. I have my array, 1, 2, 3, 4, 5, cool. And I'm going to say, well, I want to copy, or no, I actually want objects in here, sorry. A1, whoa, caps lock. A1, B2, C3. So I have in this array, and there's 3 objects. So because an array can hold any type of object or any type of element. The first element is an object with the key of A and a value of 1, so on and so forth. Let's say I want to make a copy of this. So I say var my array 2. We'll just say my new array. And I want to make a copy of this thing. What's one method to make a copy? Just talked about it. Slice. If I don't give it any arguments, it'll give me a copy of that array. So I can say my new array. So we can see, let me clear this, make the point. So if I look at my array and my new array, looks like we have a copy, right? Cool. What happens when I do this? Let's say my array at the second element, which we see as C3, we're going to set that equal to something else. We're going to set that equal to a new object of D4. Right. So when I look at my array, 1, 2, 4. What if I look at my new array? Well, it didn't change that time because I'm not referencing something else. Chrome. Oh, no, I know what it is. Sorry, this is my bad. Because those are anonymous things. Making myself look terrible. Just a second. I'll make myself look better. Terrible, right? Like, who hired this guy?
I'm just
All right, let's do it this way.
Caitlin, you know what she had sent us out like when you're lost,
I do.
like a year, right?
Yeah.
Yeah.
It's fine.
We're fine.
Felt more like 3 years, actually.
4 years.
Yeah, no.
4 years, because this is Thursday. It's the 4th day. We'll go with that.
Yeah.
All right. All right.
Why are you new?
We'll do it this way. We'll say my array. Okay, so we have those same objects as before. But what was different this time is that I created a variable A, and I set it equal to this object, a variable B, and a variable C. These are all objects in memory, and this array consists of those variables. So those are pointing to where those objects exist in memory. So now let's do this. Let's say my new array, where is it? Equals my array.slice. Okay, cool. So my array and my new array. We're at that baseline where we were before. So we have 2 arrays, each have these objects in it. Now let's say my array, let's say the first one, equal to something else. I'll set that equal to We'll do D5 this time, just so it's a little different. Cool. My array, awesome. My new array. 5, 2, 3. 1, 2, 3. What? What are you doing? Is that because it's high level? It's doing the behavior we want, but not making my point. I'll have to look into that. Why is that? Slice couldn't have changed. That's interesting. I'll get back to you on that. But I guess the point I'm trying to make is that this variable holds a reference to something. And that reference can change, or that the values where that reference is pointing to can change. Whereas if I have a reference to a string, that's just the value itself.
So this is like a shortcut for you, please.
Yeah, it is. It is.
Actual value.
And it's confusing me why this isn't.
Translating it correctly, maybe. Like my new array.
Oh, wait. No, I just realized my mistake. So I have start over. My array, my new array. So these should be what they were before, right? But if I say I have A, right? No, that didn't do it either. I'll look into it. We got to move on. But just know that when you're looking at objects or arrays, those are just pointers. You're pointing to it somewhere else. Chrome may have changed the way that they actually implement this. I don't know. I know it doesn't work that way at work. It's bitten me plenty of times at work. All right, so let's go back to here. So array.splice, extra character in this one. This is something a little different. This actually manipulates the array. And can either remove or add elements from that array. This is great when you need to remove an element from the middle of the array when you don't need a new copy of it, of the array. So that's where you would concat them. We can go over that too. Splice is where you're looking at those elements. You're saying, okay, I want to splice out this thing from the middle, and then keep the rest of the stuff in there, right? So let's say for a grades example, you want to make your school look a little bit better on paper, but even though you know there's some kids that are struggling, don't do that. But anyways, you have 28 grades, and 3 of them are bringing the entire average down. So maybe you want to see what it would look like if those grades weren't in there. You splice them out, sum those up, and then you have the result. All right, switch.
You're doing great.
Oh, wait, that's.
Yeah.
All right. Okay, switch. Switch is used very often. I mean, I use it very often, and it's used in quite a few front-end frameworks as a way to kind of control the flow of the way your data is going in, or respond to the types of data coming in through the application. Have you guys gone over switch yet? You haven't? Okay, cool. I like switch. Switch is really neat. This one I can definitely demonstrate the way I want to demonstrate it. It's confusing the heck out of me why that didn't work. Okay. So switch. Switch is, it's kind of like if then else, but geared toward the same value. You want to check if it's a different value coming in. I'll just start doing this. So switch example. I have this function, and it takes in some sort of value. And I want to switch on this value. Switch, you write it the same way you'd write a function. So we're looking at this value, and switch has these things called cases. So when this value is equal to, let's just say Joey, we'll do something with that. In the case when it's Dave, or do you prefer David? Okay, I just don't want to be, that person. Hi, Dave. All right. Now, what's going to happen is when I come across this value, it's going to say, okay, I'm going to look at all the case statements. Which one does it match? If this value matches Joey, it's going to console log hi Joey. Otherwise, if it's Dave, it's going to do that. And it also has what's called a default case. If none of those match, do this thing. I'll do this in different quotes. There we go. All right. There's another thing that we need to be aware of. And I'm gonna let it ride here. We're gonna see the behavior, and then I'll explain why it's happening. So if I say switch example, I say Dakir. What's your name again? Dakir. Right. So we saw that the default case fired, right? Because it didn't match any of the other values. If I say Joey, it actually, it's going to say, hi, Joey. Hi, Dave. Hi, what's your name again? And there's a reason why. Because when we're in a case statement, if we don't break out of it, it's going to keep going down the line. So what we want to do is we want to break out of that case. And now it's only going to do that. But that's actually very useful for it to go into the next case. So let's say that, and the perfect example is something I'm working on at work right now, where some user interacts with, let's say they click a button that's supposed to show the next screen. And when they click that button, it passes along who they are and what they're trying to do. So there's some logic in the back end that says, okay, well, in the case that they're trying to do this. And then if they're trying to do this or this, do these different things, right? So let me just actually write this out without writing anything that's like confidential or anything. In case that it is user logged in. User, let's say, not logged in. I want to break out of here. Break out of here. Default, we'll do nothing with the default for now. Well, we'll just log out. Default. So if the user's logged in, we want to do something. If they're not logged in, do something else. So we'll say welcome. And then right? Oh, switch example. So if the user's logged in, oops, welcome, right? We see that behavior. But what if we also want to say welcome in many different types of cases, not just that one? We could say, okay, well, if the case is that I'm just making this up, but if I break this, you see the functionality is the same, right? So in both of these cases, I want this thing to happen. So all I need to do is this. If it's this case, keep going, or this case, keep going, because I didn't hit a breakpoint yet. So I'm not breaking out of this switch. As soon as I hit that break, then it's out. Otherwise, it'll keep flowing into the next case because you didn't tell it. Like first did that example. Hi, Joey. Hi, Dave. Hi, what's your name? Right? I didn't break out of it. But this is very useful, right? So if you have a common result that you want to see based on those types or based on those cases, then you can kind of lump them all together, right? You don't have to write the same logic over and over and over again. That's kind of a form of abstraction too. Oh, you had a.
No, actually, I'm okay. It doesn't console log twice if you don't have a console log. So
Yeah.
like, if you don't have something after the logged in and return, then it's just gonna like take those as like one chunk and only say welcome once. Remember how the first time you said it, it went through like every single one and said it 3 times?
Yep.
So that's not gonna say it 3 times because they're like chunked together.
Right. So if I do, it's going to keep flowing through. I didn't tell it to do anything else other than look for
Other than
cases.
to look.
Yeah.
Okay, I got it.
Yep. And just whoa, switch example. It only fired once. Yep. It's not going to do it for every single case.
Right.
It's just going to, do that one thing until it hits a break, or if it doesn't find a case, the default. Right. But this value is the important thing. So this is kind of like saying value equals this. It's doing that for you. So you don't have to say if value equals this, if value equals that, right? This is just a quick way to, I have a bunch of cases that I need to look at. Pick one. Which one's true? And it has to be a single value. You can't put an expression here. You can't say, oh, this plus something else, right? It has to be the value, right? Typically, you would use this with like strings or numbers. You wouldn't typically use it with a Boolean because a Boolean is true or either if this, then it's else. So it's not a useful way to use switch. Switch is very useful when you have a bunch of like what we refer to as constants. The way we use them, it's a value that represents a string that we want to keep typing out over and over and over again. But what if that changes? We change it in one spot, so we have to keep going, finding all the places in the code where, oh, we got it to user logged in. Oh, I spelled logged in wrong. Now I got to go all right. So if I have a bunch of these strings that I'm trying to match, this is a great use for switch. Because all I'm doing is looking at this one value and figuring out which one of these it matches. Does that make sense? Any confusion on switch? At first, the case word threw me off because it was just normal way I thought about things. But then I started looking at it like I was a PI, like which case does this, which criminal this match case? I don't know. At the time, I was reading a lot of whodunit books. So I'm gonna. Oh, it's that thing again. All right, so switch logic looks at a single value and tries to match the case that is true for that value.
There's that up on.
Yes.
Oh my God. Not excited, I kinda keep forgetting. Where you going?
All right, there we go. So over in, open up a new one. Community. Students. All right, so we'll put in a new snippet. Let's say the switch statement. There we go. Okay. Switch. This is control flow based on a condition or based on a single value. Basically it. Basically uses case statements for each evaluation. And like I was saying before, this is useful when evaluating actions from a user interaction in the back end. You'll see that when we go over React too. It's a very common pattern. So if then else, this is also control flow. Does anyone not understand if then else? Okay. This is typically in line. If this, then that. Otherwise, this other thing. Object has own property. So this is check if that key exists on the object. And this is very useful. Check whether it exists on an object or trying to call it, because that will blow up. They'll have an exception. And the way to use it, real simple. I'm going to have our object, and we'll create a new object, and we'll say name Joey and speak hi. Oops, not hi. Function. Say alert hi. Right. Nope. What happened? Which is oh, alert's a function actually. All right. So now in here, if I have object, I say speak, alert pops up and it says hi. Well, if I say object.shout, we know that's not there, right? Type error, not going to happen. So what we could do is we could say if object.has own property, and we pass it a string, so it'll look for the specific key. If that, then object.shout. Not going to do it. Didn't find it. But yeah, it was like, I didn't find it. I'm cool. I'm good. I don't have to do that. But speak works, right? So it's just a way to check to see if that thing is there, if that property is there before you do something with it. And that's going to save you when you're working with, say, let's say you build a little module that a lot of other people are going to use, and they're going to pass you specific values, and you're expecting certain methods to be on, let's say, the objects they pass to you, right? Because that's what you're doing. You want to check to make sure that's there before you run the code, because you don't want to be the one that's blowing up the code. You want it to be them. Yeah, you want yours to be good, right? Especially if you ship it out to like millions of people.
So is that sort of like a test?
Yep. It's just a quick check. Is this there? Cool. True, false. That's all it returns, a true or a false. So if I said object.has own property speak, it returns true. Speak now, false. Or forever hold your peace. Okay. Does that make sense? Cool. This. This is a this is a funny thing to talk about. So this is a reference, and what it's a reference to could be different things. So there's a great. I'm actually going to come back to this one because I'm going to find there's a very good explanation of this. It's really simple and concise. I just have to find it. For now, I'm just going to put reference, and I'll come back to this. I'm trying to articulate it in my mind, and there's another guy that does a far better job of it. So I'll come back to that at the end. Arguments. So this is an array-like object of all the arguments passed to a function. Why would we need to know that? This would be great for when we have, an example would be a sum function that uses all the arguments passed into it for the calculation. All right, so if I pass in a bunch of, let's say I pass in 3 arguments to sum. If I have a logic that says, okay, add element 1 plus 2 plus 3, I can never pass in anymore. It would never work, right? So if I reference the arguments as a whole, it doesn't matter how long they are. I'll always get them all. And I think, did we do a good job of explaining this yesterday? Was it yesterday or the day before? Okay. Is there any confusion on arguments? We're solid? Sweet. State. Is a temporary place to store data. Like React or something, right? Yep. So state is a place to hold data temporarily to be used later, but not after the application is ended. So this is useful for very useful, right? So as the user's typing it in, it's storing it. And then when they hit the submit button, then it uses it and sends it off. But if they close that page before they hit submit, it's gone. Does that make sense?
Yeah.
Does that make sense for everyone? It's just a concept, right? It's just a placeholder. You can kind of think of it like a lost and found box. Put it there, someone will get it. Building's closed. Sorry, you can't get it anymore. Although actually that's not because it's still in the box. Or maybe that box gets emptied out at the end of the day into the dumpster. Sorry, so sad. That's a terrible place. I don't know why I brought that up. Okay, synchronous versus asynchronous. So synchronous is step-by-step instructions. Occurs in order, and any instructions taking a long time will block the remaining ones from happening until it completes. A lot of what we type is synchronous code. Type a lot of it, right? Most code you type. No, I'm not going to put that. Yeah, most of what you, that's how we think. Think, I'm going to do this, then I'm going to do that, then I'm going to do that. It's a very logical way of thinking. Like, I'm going to walk to the bank. I'm going to tell the teller my name, my account number. I'm going to ask for $100,000. She's going to give it to me. Maybe, maybe not. That operation may take a long time. I may be standing there forever, right? That's a very blocking situation, right? And then when the result finally comes back and says no, then I have to do something else, right? The rest of my code doesn't work because now I can't buy that house or that car. Whereas asynchronous programming is when an operation starts and the result comes back to us later, right? So I would say something like a cup of coffee. Great, it'll be up in a few minutes. I can go sit down, I can read a book, I can do all these other things. And then it says, hey, Joey, your coffee's ready. That's the result. Happened later, right? I'm expecting it to happen later at least. It may never happen. They may close the, maybe, you know, the building sets on fire or something. I'll never get my cup of coffee now. But that would be a perfect way to describe it, right? So it's something that's going to happen later, and then you'll deal with that result when it comes back later. In the meantime, we can do other things. It's non-blocking. But it's also a very different way of thinking you're writing code, right? Because you're saying, okay, well, I want to do this right after I get the result, but how do I listen for it to come back later? And that's when those callback functions come in, right? So when this result finally happens, my function calls and I can do the thing. But there's still some like ambiguity there. We're like, well, what do I do in the meantime, right? So I'm loading this page, I'm trying to get user data. Now what, right? So there's a lot of other things that you can do so that, like, say your user experience isn't terrible, right? And there's a slew of different things we could talk about there, but that's the concept, right? So what do you do in the meantime, right? So when you're programming asynchronously, you just have to think just a little bit different, right? So you have to, a great way to approach it, let's say with like a web page, would be, first thing that happens is you go and try to fetch the stuff you want to show up on the page. In the meantime, you're going to set up all the areas where that data will eventually populate. Just make sure they're there so that when the data gets back, they can be plugged into it, right? So you're expecting the data to come back. Let's put it in that place. Say you're loading a bunch of images from a remote server somewhere. So you want to set up the tags on the page that all those source tags, they're ready to go. And then when the data comes back, populate it in there. Populating data on a page. I do. Yes, we talk about poop every day. Every day.
Did you have a little boy?
I have 2 little girls.
My little girl have poop too.
Oh, they talk about poop just as much as boys.
I don't know.
Do you have the book, Everyone Poops?
We do. No, actually, we don't have that one. We have the one that says "Who flung dung." Yeah, that one's real fun.
I think that might have been after our.
But I have seen that book, yes. Populating the end page after.
Oh, yeah. That's right.
All right. Questions on synchronous versus asynchronous? Or does that kind of sum it up for everyone?
I mean, I
Yeah.
really don't have a grasp
Yeah.
of what I'm doing.
Gotcha. Yeah, it's situational too, right?
Okay.
Yeah. It's kind of one of those hard things. Well, what do I do? Well, it depends, right? What are you trying to do? Are you trying to load a page? Are you trying to submit something to an API? What are you trying to do? Yeah, that's more of like the context of that situation. Array concat. One or more arrays and joins them together into a single array. Same way you can concatenate strings, you can concatenate arrays. So if I have an array of 1, 2, 3 and another array of 4, 5, 6, I can combine them together.
But what if we just wanted to do like 2 from the first array, 4 from the second array?
You can do that. There's ways to do that. There's a bunch of ways to do that, actually.
Of course, there are.
And we're going to talk about in the second half of today. That's going to be one of the things we'll actually show. Yep. Join is for you want to join the things together and separate them with something. Typically, joining it back to a string. If I have, and I'll just go over that real quick, so we can see the difference. So we'll say our array 1 goes 3, our array 2 goes 4, 6, or 4, 5, 6. And then we'll have our array 3 I hate typing strings in array. It's just so, it takes so long. All right, array 1. So concat works on the original array. It's not a separate method. So just like array.map, it's concat. And when I say array.concat, I give it the array I want to merge it with. So array 2. And it kind of appends it to the end.
Okay.
Yep. It also returns a new array. So if I were to look at array 1, I didn't change it. Right? So map returns a new one, filter returns a new one, slice returns a new one, concat returns a new one. Well, where's my thing? So this returns a new array. Where to use this? You could use this anywhere you're combining. So you could say combining arrays of database records so that you can display it once. You don't have to do this, then this, then this. You just gather them all together and shoot them into the UI.
Maybe on the C, that's one.
Oh.
On the spreadsheet.
Yeah.
Linear population. Linear form.
I didn't write that. Wait, where?
We would have C20, like perhaps like just the way that you wrote.
Oh,
Like,
how did you say that was a great way of saying it?
Populating data in a linear form.
Oh, I see. Yeah.
Right, and then where the data ahead of you can block you.
Populate data in linear form. Maybe we'll expand on that a little bit.
Executing tasks and all there. I mean, you have code speak.
Actually, a great one would be like iteration. That's synchronous. Yeah, we'll come back to that one as well. I'll just put to-dos on these ones. We'll come up with some better explanations for that. What was the other thing? Oh, join, right? So if I have array 3 and I say dot join, well, that's not That's not great. What I can pass it is the thing I want to join with. Say I want to join the space. They'll join it with that. If I don't pass it, it's going to join everything. It basically takes the array and stringifies it and says, oh, there you go, right? It's going to throw the commas in there too. So, or I could say like this. Oh, I can't do that in the past. Whatever I pass in, it's going to join those things together and give you a string. And there's some very useful useful ways of using that, right? So if you have someone gives you an array of words and maybe you want to filter some of those out and then join them back up into a sentence afterwards or correct a sentence programmatic, maybe you could do that. Split is kind of like a similar thing. Let's say I have this string. Say, hi, my name is Billy. Split is a method on the string type. And what it does, you give it a character to split on. I want to split on the space character. And it gives me a new array. It's split on all those space characters. And it said, okay, everywhere there's a space, stop there. That's going to be another element. Stop there. That's going to be another element. And so if I were to say split and then immediately say join, I get it back. Or maybe I don't want those to be spaces. Maybe I want them to be underscores. I just took everything in that sentence, split it out, and then when I join it back together, I tell it how I want it to join back together. Does that make sense? Cool. All right, cool. Let's see, 7:15. So we're going to take, at the end of our list, I'm going to look up a great reference for this, this, and then we'll take a break, and then after that, we'll go over some ES5, ES6 stuff. Cool. Did this help?
Yes.
Okay. Oh, that's an overwhelming yes. I love it. Okay, so we'll be back at 7:31. All right, so we'll get started again. I posted a link to the spreadsheet in the CIC students channel. So we have a reference to this. And then we're going to get started on talking about ES5, ES6. What is this stuff? Does anyone have an idea of what this is? What this means?
The latest versions of
They changed the standards and following like the economic script.
Yeah, so they've evolved the standards.
Yeah.
Yep. So they've added new functionality and new ways to use JavaScript, new syntax, new functionality. I'm sorry?
Like let and comp.
Yes.
Yeah, like,
Yes.
Did you use 2015 or was it?
So ES6 is also referred to as ECMAScript 2015 because that was the year that it was finalized.
Was math teaching pre-2015?
And it would be.
Yeah, ES5.
It's not
Yep.
in ES6. Right, because ES6 introduced that.
Yep.
It didn't jive with JavaScript. Like I said, that's 2015 is what math. Sorry. just
Oh,
trying
okay,
to-
yeah.
I was-
Yeah, ES5 was finalized, I believe, in 2009. And most browsers support ES5 syntax and stuff like that. ES6 was finalized in 2015. And originally they were going to just keep saying, well, ECMAScript 6 and then 7 and then 8 and all this stuff. And they were like, no, that's going to confuse people because people are referencing it a different way. Now it's kind of referenced by the year that edition, I guess, is finalized.
Hasn't been anything since ES6 is 2015, hasn't been anything since.
There's been new functionality. Yep. ES 2017, 2018. I mean, it's every year they try to do something, right? Yeah. But this is ES6 was a big step. It was a huge step. From 2009 to 2015, a lot had to happen in order for that to actually finalize. They had to make sure they didn't break anything from the past, because as soon as you make one breaking change, everyone's code around the world stops, right? And that's not good. Yeah, it's just ECMAScript is the official name for JavaScript. JavaScript is actually copyrighted, I believe, by Oracle. That's just most people refer to it that way because I'm sorry. ECMAScript. ECMA. Yep, script. That is the official name of JavaScript. It's also ECMA is also the standards for that language. And there's a committee that gets together. It's called the TC39 committee. There's 39 chairs on this committee, and they get together and they go through all the wants that the community wants with the next edition of JavaScript. Right? And they go through it all and they figure out, will this break this? Will this break that? What makes sense? Maybe we should do this later. And the reason a lot of things took so long between different editions of it is because no one could decide. Like, well, it's kind of like split in half for a while. Like this side wants this side wants that, until finally they said, well, this is silly. It's been so long. Let's just do it a little bit at a time. We won't make these big changes. We'll just make yearly updates or whatever they need to do. So this committee decides, like, okay, and they're very knowledgeable people, that they work in this stuff all the time. It's mostly companies that represent. They hold the chairs, because those are the stakeholders. They want to see the language evolve because they use it. They generate modules for it, and so forth. That's like a high-level community approach to it. Yeah, it's like the JavaScript of Thrones.
Right.
Yeah. All right.
Did you put those anywhere?
Oh, this?
Probably, yeah.
Did I not post the slide? I may not have. Okay, cool. And for those that wanted more examples in the slides, I'm sorry. This is still in a state where we didn't put them in, but I can paste them in as we go along. All right, so ES5, ES6, we kind of just went over that. Which or when to use? When do you use it? When do you not use it? So it's pretty much safe to use ES5 syntax, right? Because all browsers basically support this, including backend development paradigms like Node, right? It's safe to use that. When to use ES6? Well, you use it when you know it's supported, right? And most modern browsers, I say modern, when I say that, I mostly mean like Chrome, Firefox, even Safari, and
Not Internet Explorer.
basically, yeah, not Internet Explorer. So Edge is actually going to, under the hood, it's going to implement Chrome's engine going forward, because I think they just kind of gave up and said, well, we can't. Well, you know, Microsoft is a very special flower, and they want to do things their way. So I work with Microsoft technology all day long. It's fun. So Edge, Chrome, Firefox, Brave is a new browser that just kind of came out recently, which actually was partially created by the person who created JavaScript.
What was that one that you noticed? Right. that was
Brave.
one.
Yep. So those are what I refer to as modern browsers. So if you think of older things like Internet Explorer, basically, and everything before that. Yeah. That you're not going to be able to use ES6 stuff there. And if you are, it was probably experimental at that time. So it's pretty safe to use ES6 a lot, but there will be instances like if you need to make sure that all of your users, depending on whatever browser they happen to be, maybe you support back to IE9. You don't necessarily want to write in ES6 all the time because you've isolated those customers or those users. And there are ways to compile ES6 down to ES5. So there's tools to do that. So internally, at wherever you're working, let's say like at work, we use ES6. We write it all day long. But when the code we actually ship gets compiled down to ES5, right? So that we're not isolating too many people. Because, we have to build our business. So that's basically the which and when to use. So it's safe to use ES6 if you know that you have a tool to compile it down and cater to your other users that may not have a browser that can access that or can process that. All right, so variable declarations, the way we declare variables has changed a little bit. We have more options there. Let's go over that real quick. Did you guys go over var, let, const, the differences between them? Do we need to go over it again? Okay. We'll do it this way. So there's a lot of opinions on. Well, there's a few opinions because there's only 3 of these things, where people say always use const, except when you have to use let. And then there's people that say, well, always use let. And then there's people that say, use whatever you want. I would say make your own decision as long as you know the difference between them, right? So the way I personally use it, from my personal experience, is when I'm using const, I'm usually referring to a value that will never change or that I never have any intention of manipulating. Because, let me just do this. We'll say var.
You use var.
Hmm?
You use var still, right?
I've been using it in here simply because I didn't get to the ES6 stuff yet. Because I didn't know how much of that you guys had gone over. So I'm going to do three of these here. We'll do var, let, and const. And we'll say v object, l object, and c object. All right, so these are all going to be objects. They're all going to reference the same basic thing. So v object
You got equal sign.
did call. All right, so whether I use var, let, or const on an object, let me actually do this. This will illustrate the point better. Right. Okay. So if I initialize a variable and I set, if I use var, I say v string equals a, can I change the value in here later
For bar,
for var? Yes.
easily.
Yes, we can change.
So fun.
What if it's a let?
Yes.
We can change. What if it's a const?
No.
No,
Well, maybe you use,
can't change.
wait, constant.
It's
Yeah, but you can't. The binding change the constant.
we're gonna get. I know what you're trying to say.
Okay,
We're
well,
gonna-
no, I just feel good that
Yep.
I have a clue somewhere.
Yes,
but
I
it's
know.
book knowledge. I
Yes.
read it, I'll stop.
So with strings, this is pretty easy to understand, right? If I use var or let, I can change that later. If I use const, no, it's constant. That's it. It's done. Var for an object. Can I change that object? Can I change the properties in this object? Can I set a equal to 2? Can change a. Can I do it here?
Yeah.
Can I do it here? Yes. Why can I do it here? Anyone will take a guess?
Because if it's an object, you can use a method on it.
Oh. It's just A, there is a variable and not a value.
No.
Does this have to do with the reference?
Yes.
Like you're referencing a.
What's held in C object is a reference to that object, not the object itself. So you can never set C object to another reference to anything else. But you can change the object there. You could just never change the reference to point to something else. That's the big difference. And that kind of goes back to where I was talking between values and references, right? So this is where just a simple thing like that, just knowing about that is very helpful, right? Is that what we were trying to articulate? No?
Not quite.
Not
You're
quite.
getting there.
Okay. Okay. Yes. So
The constant isn't always constant.
it is always constant.
It's always constant.
It's always constant in what it's
Exactly.
referring to, right? Yes. So if it's a reference to something, you can't change that reference. It'll always point to that reference. If it's a string, it'll always point to that string, right? But you can change the object it's pointing to, right? So in fact, it's no different than var or let in that sense. It's only saying, hey, you just can't set me to point to something else. But you can change that object however you want. You can also do this. And we'll get into the syntax in a little bit. But you can create a function using const. Because a function, in this sense, is an expression that gets evaluated to that function. and you're setting a reference to that function and by using const. And we'll get into this as part of the whole ES6 stuff. Did you guys do arrow functions yet? You didn't? Good. So I'll get to cover that. He probably, yeah, you probably have seen them, but what they probably weren't explained. Okay. We are definitely going over that today. So var, oh, so you guys talked about scope, right? You remember function scope? Global and local. Yep, so var obeys scope, but it obeys function scope. So if I have a function, my function, because I got no better name for it. If I declare var a equals 1 in here, and I console log out a down here, can I find it? If I were just to run this, what would happen?
No, you're outside of the function.
Oh, I'm still, hold on a second, I gotta refresh my page. A is not defined, right? Is actually defined in this scope. This function has its own scope. So var obeys function scope. Let also obeys
So if you move the curly brace outside of the console log to the bottom, like to line 6, then it would work.
Because you're within the
Right.
same function.
oh, if this,
If you
Yeah.
put console log inside the function, then it'll work.
if I put it in the function,
Mhm.
I have to call the function. Yes. Yes, that works. If I were to do this, because it has a reference to A. Oh, I see it. It's right there. It's in my scope. It's not in this one. But what if I were to do this? What's it going to show? Right? Because that's its first known reference. Whereas if I take this out, it keeps going up the scope until it finds it, until it gets to the global scope. And if I can't find it there, it says, nope, you didn't define that. I'm not doing it. Sorry, not sorry. Okay.
So aside from making grave error, is there any reason why you would do that? Like name your variables A?
No, no, don't use A.
I mean, is there a reason why you would name it the same thing inside a function and outside a function?
You typically want to avoid it.
Okay.
Yeah. Because then it just looks confusing.
Yeah. That's
Yeah, yeah.
what I think of the pen,
Right. The whole thing when I was trying to do the animal with the speak and I couldn't think of another word because naming's hard. It's like, I just want to call it this and I want to call it this here because I'm thinking about the same way, but you can't because this name's here and it's terrible. All right. But it does obey scope. Let also obeys function scope. So let is kind of like the same thing, but let also obeys other types of scope that var does not. So var does not obey local scope. It obeys function scope, and there's a difference. So I'm going to do this. We'll have var at the top, and inside here I'm going to put 2 other curly braces. Actually, let me do it in here. You can do this. Is actually perfectly legitimate. When you put things in curly braces like this, you are defining a block of code that has its own local scope to it. So if I were to do this, say console.log a, and I run this function, it logs it. If I change that to let, I have to refresh my page. Apparently I did that somewhere else. It's not defined. It's defined within this scope, not the function scope. So it obeys that local scope. Like it does what var was originally supposed to do. But that was, I think that was the guy who wrote JavaScript. I think he was quoted as saying something like, var was like one of my biggest mistakes. Like the logic was one of the biggest mistakes. Like it should have done this, and or maybe it was the how many equal signs or something like that. But there were a lot of like it was a project that was rushed, right? So let kind of it takes care of the var situation that it should have had in the beginning. Const is the same way. The only difference between let and const is that what we went over before. You can't reference something else. Can't change that value. You can't change the value, or you can't change the reference to what it's pointing to. But both let and const obey the same scoping laws, where var does not. It only obeys function scope and global scope. That's it. Doesn't matter where you nest it. If it's in this function scope, it's there. So I typically never use var, but there are instances where I do use it. It's very rare, but there's situations where you're like, yeah, actually the most of what I use it for is when I'm experimenting in the console. Because if I do this, if I say const t equals time, like, oh, I want to change that. I want to say var, or I want to change it to something else. T equals not time. Can't do it. It's been defined already, right? And I'm just experimenting. I don't want to have to go through this whole rigmarole, right? So I could say var y equals y. Oh no, I didn't want it to mean that. That's okay. That's fine. You can keep redefining that. That's mostly how I use it when I'm experimenting. Otherwise, it's either let or const. And my reasoning for using either let or const is I use let typically when it's just some variable I've created and I really don't care. I'm just going to use it in this thing and never use it again. Const I use for things like functions that I know never need to be redefined, or constant strings that are defined throughout my entire application. Things I know that I will never change, not necessarily that are temporary. So let I use more of like a temporary basis. Like I'm only using it in this function body, I don't care. Right? Other people will say, no, use const. Well, up to you. As long as you know how it's obeying scope and how you're using it, that's fine. People will always argue on that, I'm sure. All right. Are we good with var let const? Functions. So here's the fun stuff with functions. I could define a function this way. Perfectly legitimate. I can also, let's actually have it do something. No, let's have it return a value. Word value. So when I call this my function, I see value. It returned a value. That's one way to write a function. Another way to write a function is saying, and this is a quote unquote old way. We could save that function to a variable, because a function is what's referred to as a first class citizen or first class object or first class value. You can treat it like any other value or any other variable, right? You can store it in things. You could pass it along to other functions. Functions can return other functions. Pass around like anything else. So those are two ways to declare a function in ES5. In ES6, we can do this. So this is a shorthand syntax that just says, these are my parameters, and these get shoved into this function body. I think of it like this. This goes to here. Like when I see an arrow, I think, oh, that goes somewhere. That's how I think about it. I don't know if it helps you. But we don't have to write the word function. Okay, it's here, but that's just the name of the variable, right? We don't have to actually write the keyword function. We could just do this. These two parentheses represent these two parentheses. And this arrow represents the fact that it's a function. Right? So far, are we good so far? Okay. What's useful about that is, let's say I have an array. I want to map over it in a callback function. I'll have to write all this thing out. Right, so I'm doing all these things. That's a lot of thing. I could just do this. I save myself some typing. And once you're familiar with the syntax, you know that map passes the element in the index. Those things go into this. This is where they'll be processed and returned. So that's another way of writing a function. You'll see this a lot for like callback functions. It's a quick way of saying this goes to this. This is the function, instead of having to define all these things. Right. Now this is an anonymous function because there's no name to it. A lot of times you'll see callbacks with no names on them because it's just used there and that's it. I know there are people that name every single function, even if it's a callback function. And the usefulness of that is that if there's an error in that function, it'll see that reference to that name in the call stack. Yeah. And that whole log of error jargon that comes out. It was that callback function. I know where the error is happening. Whereas if you don't, it'll just say an error happened. Yes, not fun. So I typically don't name my callback functions, but you can either choose to or not choose to. All right, so that's another way to write a function. Now there's two ways to return value in these functions. One is an explicit return, and one is an implicit return. And everyone's familiar with the concept of explicit and implicit, right? So I could say for equals. This is an implicit return. Now there are rules behind using an implicit return. The first rule, and the most important, is that it can only be a one-liner. It can't have, why is this jumping all over? See that? We're gonna kill that tab. I don't know why that's happening. Because it's Thursday and it's 8:04.
Try to resize it.
Yeah, maybe. Okay. So this is an implicit return. I don't have to write the return keyword. I don't write the curly braces around it. Also important. The second you include curly braces, it's expecting an explicit return, which means you have to use the return keyword. In fact, I'm going to call that function 5. Oops. This was the implicit return. you can still put semicolons there. Implicit. Return. Explicit. Return. So why would I want to use an explicit return? Any ideas? I need more than one line of code in here. You can't do multi-line function bodies with implicit. Well, technically, no, you can't. Sorry. So I were to, let's say I want to process something. Right, so I want to do something with it and then finally return it. That's the usage for it. Now there's a little gotcha too with some of this. So let's say let's say my function 6 returns an object. Uh-oh. That curly braces. It's expecting it to have an explicit return. So how do I do that? Without making it a multi-line, keeping it implicit. Any ideas? No. No, then it becomes a string. Yes. The reason parens is that represents an expression to be resolved to a value. So this will resolve to an object, and then it'll get returned. Okay. Let's see. Did I go over everything? Yeah. Oh, there's one more. So my function 7 takes an argument a, oops, equals, too soon on that, and it will return a plus 1 implicitly. So if I were to call this and pass in 1, I would get a result of 2, right? This plus this. So I putting that inside the parentheses. I could also do a b. So just same way you're doing before, except it's still just no function keyword. That's in one argument. Okay. Actually, I'm going to make this 9.
All these do exactly the same thing, and it's just a matter of what you prefer or what your company prefers.
Or whatever the context is, right? Yeah, if you want to save a few lines, why do a multi-line if you know it's only going to be one thing that you're doing? Now, if you only pass one argument, you can do this. You don't need the parentheses. If there's one, the second you have more than one, you have to wrap it in parentheses. Otherwise, JavaScript has no idea what this means. It actually thinks you're trying to you're maybe in some object or something, right? So as long as there's only one, you can exclude the parens. And those are all the ways to write functions. Any questions on this? Do these all make sense? I mean, it's a little bit different syntax. You've probably seen it already, right? Especially if you looked at other material, right? They're used all over the place for their simplicity. Actually, there's one other thing I need to talk about with arrow function. These are called arrow functions. And that happens to do with the this keyword. When you call a function this way, and I have a reference to this, that is different than if I refer to it in an arrow function. What this refers to is different. When you use this inside an arrow function, it refers to whatever is calling that function in the scope that it's being defined. Right? So if I have a function inside this, let's say I'm referencing an object that has that's not a good example. If I have a function inside another function, the inner function is an arrow function, and I'm referencing this inside of it, this refers to that scope of that outer function. And it's always going to refer to that. You can never change it. If you need to change it and you need to change this reference, you have to use the other way of writing a function by using the function keyword, right? This is bound explicitly to its lexical scope, right? Where it is defined in the code. It's always going to be that. Now that's good if you always need it to be that. But if you forget, and you're like, oh, I need to bind it to something else, it needs to be a different this, you have to use a different function or rewrite it, right? So that's kind of like a more of an advanced case. You probably won't be doing a whole lot of that. I don't do a whole lot of that. I think I've only had to maybe a handful of times, maybe. In most cases, I just use arrow functions now. Because of the way that we write code, we're being very explicit about where these functions are referring to things. But that's just kind of like a gotcha, right? Something to be aware of. And you'll remember it the first time you realize it's not working. That's how I remembered it. All right. So functions. Are we good on functions? Cool. Oh, yep. Before I get rid of that, yes, absolutely. And we'll have time for one more ES6 thing, but it's used, well, we'll do two. We'll have enough time for two. And these are used extensively as well.
Are you viewed as like cool if you write ES6 style versus?
Not anymore. Now you're just normal.
Yeah.
Yeah.
Okay.
You used to be cool. Now it's like everyone's doing it. You're not cool anymore.
So like, if I write function, my function really braces everywhere, it's gonna be like where what's temporary.
No. Well, hopefully they don't. It's a terrible way of thinking about it. No, it's common enough now that if you see either or, it's like, okay, I think of it like if I see a lot of arrow functions in a module and I see one function, like, oh, that probably can be bound to something, some other this. See, now I think about it, right? Because if it stands out, why is that one function? Oh, it's probably because you can bind it to something else, like the call to slice to get arguments, right? You can change its binding. Okay. So now, let's see, let's go back to the slide. Array properties, array elements. Okay. We're going to talk about two things. One is called destructuring. Before we talk about destructuring, we're going to talk about, actually we'll do this one first, the spread and rest operators. Anyone heard of spread or rest operators yet? Okay, they both use the same ... operator, but when they're used means something different. So spread, we'll do this. We'll say var array one equals 1, 2, 3. Remember how we were trying to concatenate two arrays? I want to concat these two arrays. instead of using concat, I can create a new array. I can spread the contents of array 1 in here, and I can spread the contents of array 2 in here. This will give me a new array of 1, 2, 3, 4, 5, 6. So yeah, so spread means take everything in this array and one by one plop them in here, one at a time.
That's where we just like a name with the letters.
Oh, okay. So you had already had that exercise?
Yeah, we did it on pre-code.
Oh, cool. Excellent. Does that make sense? You can also do this with objects. Right, so I can do the same thing with an object. I can say spread all the key value pairs of object 1 in here, and spread all the key value pairs of object 2 in here. So this will produce an object with the properties and value, the properties from every single object you spread into there. And it's a brand new object, yes.
That's really useful.
It's extremely useful. I use it all the time.
Yeah,
It's
That's really
It's very, very useful. Without this syntax, to rewrite this is a lot more lines of code. You have to loop over each one, loop over the other thing, right? And then actually what you would do is you'd pass in an array of objects and you'd loop over the array. And then for each object, you'd just call keys, then loop over each key. And it's a lot of lines of code. Now it's just 3 dots in front of that object or in front of that array, right? That'll produce that. Super handy. You just have to know what that operator means, right? Now that's the spread operator. REST uses the same syntax, but in a different place. So this is spread. Oh, it doesn't really matter that. When used in a function signature as a parameter, what this is saying, I have argument 1, argument 2. Every single argument after that, take all of them and put them in an array. Now all other args is an array of every single argument from index 2 on.
You can have like
As many as you want. That's the same thing as calling array.slice.call arguments, comma 2, like we did before. Now we just put 3 dots in front of a variable name, and now we have an array of every single argument after arg 1 and 2. Or maybe we just want all of them. All args in an array. We can iterate over it nicely. You don't have to do anything in between. So that is the REST operator. And that's the sole difference.
Just fingers of rest.
Yeah, I like it. Yeah, so it's where you're using it. That's what it means.
Sorry, so we had argument 1, argument 2 before.
Mm-hmm.
It meant not argument 1 and 2?
Not argument
Just
1
the
and 2,
rest. Okay.
just everything after that.
Gotcha.
But if it's only ... args, it's every single one. Yep. And that's spread and rest. That's basically it. Yep. Super simple, super helpful. Just have to know what those 3 dots mean and where you're using them. Yep. Okay. All right. destructuring. Actually, before I'm going to do destruction as the very last thing I talk about, I'm going to do one quick thing. Default, remember default values? Options equals options or this empty object. Yeah, we don't have to do that anymore. Okay, give it a name. Element. Remember, it took a type, options, children, and before we had to say options equals options for an empty object. So we have a base. We don't have to do that anymore. That's the default value. If I don't pass options in, it defaults to whatever I set here. Done. If I don't pass in a type, maybe I always create a div. You didn't give me a type, so I'm going to create a div. Right? It's just you're setting the default value by using that equal sign right after the parameter. Pretty simple, easy. I'm glad it's there. It saves me a lot of typing. Right? It's kind of, you can kind of reason about that really well. You say, okay, I'm going to call this thing type. No, well, if I don't do anything, it's going to be a div. Otherwise, it's going to be what I tell it. Right? Really handy way of defining default values. That's all I have to say about default values. Now the thing that is a slightly more complex than the other things. So destructuring, I'm going to set up two objects. I'm going to set up an object, and then I'm going to set up an array. Real simple. So 1 and 2. Two properties, two elements. So if I wanted to say this, I would say, maybe I want to save the property or the value of property A into a variable to use later. I would say var A equals object1.a. Easy, cool. And then for arrays, I want the first element, or oops, var, we'll say L1, element 1 equals ARR at the first index. So var A equals object.a1, object1.a. With destructuring, there's another way to write that. So this is the same thing as this. What it's saying here is it's saying let, I'm declaring a variable name. I'm expecting that this name is going to be the same name of the property in the object. So this syntax here says, okay, I think of it like this. There's an object that I'm pulling this out of. There's a property named A in this object. This is the object that has that property. So from then on in my code, I can reference A and get 1. Do I need to say that again? Or
Maybe like A needs to be like has legs.
maybe. Why it might be better. I only want to reference A, and for the rest of the remainder, I want all the other properties. That's another object. I spread the rest of those properties into this variable. But these are variable names. What's important to note is that this variable name I'm declaring is the same name as the property on the object. I can't say C and expect to get object.a. This would fail because there's no object1.c. But there is an A, and there's also a B. I can pull them each out, as many of those properties that are in there. So from then on in my code, I have a variable called A and a variable called B, where A is equal to that property value. this property value is B. It's just another way of writing it. You're saving yourself lines of code. Otherwise, you'd have to do this. Right? But there's also that handy little thing like, okay, well, all others go into this object and maybe I'll use that for something else. But that rest operator can only, it has to be the last thing, whether it's in that function arguments list or in this sort of syntax, it has to be the last thing. I can't say all others, oh, that and C. Not going to happen. C is not going to be populated. It'll actually throw up at you and say, no, you can't do that. I don't know what you mean, right? So that's what destructuring is. I always thought it was a funny word for it, but once you get used to what it is, the word just lets you remember the pattern. And it works on arrays too. But we're not using property names. Instead, we're using the index of where it is. So if I wanted element 1, I would we'll use a let. Let, I'm destructuring an array. Okay. What am I going to pull? I want to pull out element 1, and I'm going to call it element 1. Now, because there's no name to it, I get to tell it what the name is. But it's in the order that you do it. This will be 1, this will be 2. And the same reason that if you look at this, pretend this is just its own array. This is element 1. This is the index 0. This is at index 1. This is at index 0. This is at index 1. So but you'll still refer to it as element 1 going forward. That's the variable name that's holding the value. But you're pulling out the element at that index. This would be an array of 3, 4, 5, 6. I'm just calling it all others. That's equal to an array of 3, 4, 5, 6. But element 1 will be an array of 1 or value of 1. I think it's just the value. Oh, I can't run all that. R equals 1, 2, 3. Right, and if I say let A, B, and C equals, good, there's code completion. A is the value, okay, right. But C is actually an array of stuff. Well, it's 3. Let's make it a little clearer that it actually is an array of all the other stuff. Oh, that's right. Again, I should have used var. Okay, C is an array, whereas A and B are the values, right? So I'm spreading, or I'm getting the rest of these things and putting them in an array. These are those values at index 0 and 1, so forth. So as long as you remember that you're getting it from an array and you know the index, that's what's going to be plopped in there. All right. Questions on destructuring? That's all there is really to that. There's a couple more things I could show you. But are there any questions on this? Does it make sense? Just new syntax to learn, basically. It saves you typing. But there's another great thing about destructuring that I really love, especially when it comes to React components. I'm just going to write a component out. I'm going to create one. It doesn't matter that it's a React component. Components are still just functions that return something that is renderable. So I'm going to call it message. And this message function takes this thing called a props object. It's an object that represents all the properties I should put on this message component. And this returns, again, don't worry about the syntax. Just know that I have a component called message. It takes some options. In fact, I'll just call it options. Make more sense. And what this is essentially it renders a paragraph tag into the DOM, where when I pass in this options thing and it has a message property, that message is going to be in the paragraph tag, right? But I have to say options.message. I know that what's being passed in is an object. I know there's a property called message. I can use destructuring right here. Just grab that. I don't have to say options dot. That's all I care about. I don't care about all the others. Or if I do care about all the others, then I can use them. And I would say all others dot whatever if I had to. But I'm explicitly pulling out this property off that object and then using it. You can do that in any function that gets past something that can be destructured, whether it's an array or an object. Right in the function signature. Very helpful. Another really cool thing is you can pull it out and give it a default value. So if you don't pass it in, at least it won't blow up, right? Or it won't show undefined. And the user be like, what? Yeah. Super helpful tools. A lot less code to write than what we had to do before. Does this make sense? Okay. I'm going to put some notes around this and post it in the Slack channel. But that's really all I wanted to cover for today. So I'm glad I was able to cover all of this. Any last questions on this, or anyone confused on this? I know I say that and you'd be like, oh yeah, it makes sense. And then you go home and be like, oh, what do I do again? It's just, you just got to practice the syntax, right? So I did post a reading assignment in the module for day 3. We were originally going to cover this yesterday, but that's okay. We went over a lot of stuff that was really important. Because originally today was just supposed to be like a recap day if you had any final questions on any JavaScript stuff. But we kind of addressed a lot of that stuff throughout the week. So this kind of worked out really well. But in the reading for day 3, is it day 3? There is references to ES6, a book called, what was it called? Something to do with evaluating ES6. I forget, but there's a lot of good stuff in there. And I'm going to post another reference to an author by the name of Kyle Simpson, who has a series of books called You Don't Know JS. And there's a really good book on ES6 in there. So I'm going to pull it up real quick just to show you. But oops. He goes by the name of Getify. This is Kyle Simpson. You don't know JS. You don't know it. So here's his books. They are free. They're up here for you to read. If you want to purchase them, you can. I did purchase them because I like having a physical book in front of me when I'm reading a book. I don't know, call me old school. But there's some really great stuff. So we just went over some of the ES6 stuff. This and object prototypes, super helpful. He goes into a lot of stuff with scope and closures that make a lot of sense the way he writes. He writes in more of like a plain English type of thing, right? He doesn't use a lot of jargon. He has a lot of great examples. The one thing to get over is that when he defines functions, he calls them foo and bar and baz. He doesn't like to use like functions you would probably call things, but he has his reasons for it. His reasoning is that if I call it this, then you lose what I'm talking about. You think it's only referencing like a form or something when it's not. Foo is just a placeholder for some function, right? So it's just one thing to kind of get over if you do read that stuff. But a lot of great material, all free. Another one that I recommend of his is Functional Light JS. So you hear references to functional programming. We went over map and filter. Those are like functional programming techniques, methods you can use in functional programming. He talks about those as well. So if you want to get more into that stuff, you can. Great resource. And that's it for today. All right, thanks guys.
Thank you. The spreadsheet was.
Glad it helped.